Hello everybody, and welcome to another exciting installment of Your Math Teacher Talks to an Empty Room. Today we are talking about slopes of lines. This is going to be somewhat of a review from things we have already done, and it is not going to be all that difficult, so let's try to get through this video quickly. But I want to stress that this is a very, very important one. If you cannot figure out slopes of lines, all of the rest of your math courses will be very, very difficult because basically everything from here on out has a huge slope and graphing component. Okay? So this is one of the very, very important lessons we have to learn. First of all, do now. Joseph plots a graph of his 300-mile trip to the coast. And the graph is actually provided for us here. The question is to calculate his average speed for the first 3 hours. A hint is given to you. Divide the distance traveled during the first 3 hours by 3. So what you are going to do, you're going to pause the video. You're going to try to answer this question. You're going to come back and see if you got it correct. Go ahead and pause it now. Okay, welcome back. We have that he is going a certain distance over a certain amount of time. We have this 3 hours is what we are asked about right here. So this is the part of the graph that we actually care about, the one that I have highlighted right there. Okay? And what we're going to do is we're going to see his average speed. And what we have to do to get his average speed is take the amount of time, which is 3 hours, because he went from 0 to 3. That's 3 hours. Okay? So we have 3 hours, and we look at the total distance. He went from 0 to 150, so 150 miles. And then to find his average speed, it's just distance divided by time. 150 miles divided by 3 hours. 150 divided by 3 is 50. And so he's going an average of 50 miles per hour. Okay, that's all we have to do. That is the end of the question. We will see later on how this is related to slope, so that's why we had this do now question. But for right now, we are done with this question. Okay, so we talked last time about the rate of change, and we did some work with that, and everybody thought it was fairly easy. Now, when we talk about a linear equation, that is, when we graph it, we have a straight line, then we know that our rate of change is going to be constant. And the constant rate of change of a line is what we call the slope. Okay? So what we are going to do is we're going to talk about 3 things. We're going to talk about the rise, the run, and the slope. So first thing we need to do is pick 2 points on our line. I'm going to pick this point here and this point here. Okay? And what we're going to do is talk about the rise between these 2 points. That is the change in the y value, how much it goes up from one to the other. And this is actually already drawn for us in this dotted blue line right here. Okay? It's how much we go up from this first point right here up to this second, to even with this second point. Okay? So we're going to try to find that distance, and that is what we're going to call our rise. Okay? The definition of that is the rise is the difference of the y values of the 2 points on a line. Okay? And our rise right here is going to be 3, because it is 3 units difference from the lower point to the higher point. We've gone up 3. Okay? The run, on the other hand, is the difference in the x values of the 2 points on the line. Okay? So what we are going to do, not only are we going to talk about our rise, but we're going to talk about how far it is from our first point here across to where we are even with our second point. And if we do that, we see that it's already done for us. This dotted red line right here is going to tell us, is showing us how far over it is, or the run. Okay? So the run is the difference in the x values, and for this case, the run is 2. All right? So because this is a linear equation, no matter which 2 points we pick, let's say instead, I'm going to erase this first one, and I want to pick this point and this point. Okay? Once again, I have a rise right there. I have a run right over here. And because this is a linear equation, no matter which 2 points I get, my rise and my run should be similar. Rise is 3 here, run is 2. Okay, if I pick these 2 points instead, this one here and this one here, and if I go up 3, anytime I go up 3, I will have to go over 2. So my rise and my run is just repeated over and over and over again, forever, because this line goes on forever. And then when we talk about slope, all we're doing is finding the ratio of our rise to our run, just like rate of change when we were doing it last time. So we take our slope, right over here, is going to be equal to my rise, 3, divided by my run, 2, so 3 over 2. Okay, so that we're going to call that the slope. It's the rise divided by the run. And another way of saying that is, what is my change in y? And let me divide that by my change in x. So change in y divided by change in x. That's all slope is. Just taking a simple couple of numbers and dividing them by each other. So let's do a couple of examples. We're going to find the slope of this line, and we have these 2 points that are given to us on our graph, 1, 2, 5, 4. So first thing I want to do is figure out how far did I go up from one point to the other. Okay? And when I'm talking about going up, I'm talking about my y values. They tell me how far I've gone up. I go from 2 to 4, so this distance here is 2. And then when I'm trying to find my run, going over, I look at the x values. 1 to 5, that tells me that when I did this here, I went 4 units. And then what I'm going to do is I'm going to take these two numbers, my rise, divide by my run, okay? And I get that it is 2 divided by 4, and I will simplify that to 1/2. And I can't do any more than that. My slope is going to stay 1/2. Do not turn it into a decimal. It is much easier to work with it as a fraction. So the slope is 1/2. Okay, now we're going to do another one. Once again, we have a different line here, and we're going to find 2 points. They're already given to us right here. There's 1 point, there's the second point, and I want to find my rise and my run. Again, the rise is the y values. How far is it to get from -2 up to 2? Well, I go 2 to get to 0, another 2 to get to +2, and so my total rise is +4. Then to find my run, I look at the x values, -1 to 3. How far is it there? Well, I go over 1 to get to 0. Another 3 to get to +3. And so my total run is also 4. And so I write that my rise over my run is 4 over 4. And when I divide that, I get that my slope is 1 over 1, which is just 1. Okay. That's all we're doing. My slope is 1. Now let's compare these two lines. I see that if I'm talking about the steepness of this line up here, this line right here is a lot less steep than this line. Think about trying to run up this line right here, the second one. That would be pretty tough, but it would be it would be much easier certainly to run up the first one. Okay? And if we look at our slopes, that's exactly what the slope does. It measures the steepness. This slope of 1/2 is less steep here than a slope of 1. And that should make sense because the bigger the number, the steeper it is. Okay, so this bigger number 1 is steeper. So keep that in mind when you're talking about slope. What we're doing is actually measuring how steep a line is. Okay, it is now your turn. Go ahead and try to find the slope of this line. You'll need to find your your rise and your run and divide them. And then we're going to move on here. Finding slope without graphing. Okay? So the first example we did is we were trying to find the slope, and we had a graph, and we were able to count how far up and how far over our rise and our run. It turns out that we don't actually need to do this because we actually have a slope formula. So as long as I know my 2 points on a graph, I can figure out the slope of my linear equation. Okay? If you know any 2 points, you can find the slope of the line without graphing. The slope, which is represented by m, it's not really easy to figure out why it's m, but that's what we do, so we just have to remember it. It's represented by m, so the slope of a line through the points x1, y1, and x2, y2 is this formula right here. y2 minus y1 divided by x2 minus x1. Okay? This is a lot more clear once we do an example, but what you have to keep in mind is if you have 2 points, let's say we had 2, 3 and 4, 7, just to pick some points at random. You need to pick one of those points to be x1, y1, and the other point to be x2, y2, and then we just will plug these 4 numbers, 2, 3, 4, and 7, into where they go in this formula here. This formula will give us our slope without having to graph it. So that's going to save us quite a bit of time. So right now, we're going to find the slope of the line that passes through -2, -3, and 4, 6. And what I'm going to do is I'm going to pick one of these points to be x1, y1, and the other one to be x2, y2. For the first one, I'm going to do it both ways to show you that you get the same answer both ways. Okay? So let's just say, for the sake of argument, that this here is x1, y1, and this here is x2, y2. Now I'm just going to start with my formula. M equals y2 minus y1 over x2 minus x1. Okay? I'm going to give myself a little more room. So, all I'm going to do is start plugging in numbers now. I know that y2 is going to be 6, because that's what it is right over here. So I get 6 minus y1 is -3. So here's where you need to be careful. It's not -3, it's minus -3. This minus sign will always be there, and then it's just a matter of whether or not the number going after it was positive or negative. So right now we have 6 minus -3, and we're going to divide by x2 is 4, and x1 is -2. Once again, I have to remember to put in my negative sign. And then I need to remember that when I am subtracting a negative, that's basically the same thing as adding. Same thing over here. When I'm subtracting a negative, it's basically the same thing as adding. So I'm going to rewrite this. Well, first I'm going to shrink it down and give myself some more room. I'm going to rewrite this now. I get 6 plus 3, which is 9, over 4 plus 2, which is 6. These have a common factor, so I'm going to divide by both top and bottom by 3. And I get 3, I get 3 over 2. These do not have a common factor, so that is my slope. I am done. My slope is 3 over 2. Okay, so m equals 3 over 2. Now what I'm going to do is I'm going to do the exact same thing, but instead of x1 and y1 being the first point, I'm going to change it to where it's the second point, and x2, y2 will be the first point. So let's do it like this. x1, y1, x2, y2. I've just switched them. And I'm going to do my same formula. M equals y2 minus y1 over x2 minus x1. And now I'm just going to plug in numbers. M is equal to y2 is going to be this guy here, negative 3. Y1 is going to be this guy over here, 6, so minus 6. X2 is going to be this guy here, it's negative 2. So I do negative 2. And then finally, x1 is going to be 4, so just minus 4. Now I'm just going to do my math. M equals, well, negative 3 take away 6 is negative 9, and negative 2 take away 4 is negative 6. Well, dividing for negatives works the same way as multiplying. When I have a negative divided by a negative, that just becomes a positive number. And then I have 9 divided by 6. Well, I can again divide by 3, and I get 3 over 2. So my slope is 3 over 2. Notice I get the same thing no matter which way I do this. So it doesn't matter which point we pick as x1, and which point we pick as, or x1, y1, and which point we pick as x2, y2, just as long as we have plugged in our numbers correctly. So let's do this one more time. We're going to start m equals y2 minus y1 over x2 minus x1. And I am just going to randomly pick the first point to be x1, y1, and the second point to be x2, y2. And now I'm just going to plug in my numbers. I get that m is equal to y2 is 3, y1 is negative 6, x2 is negative 2, and y2, or I'm sorry, x1 is negative 4. Be very careful with the negative signs. Now what I'm going to do is just calculate here. 3 minus a negative, that's the same thing as adding, so equals not 3 plus 6 is 9. And then negative 2 minus a negative again is the same thing as adding. I get negative 2 plus 4, which is positive 2. These do not have a common factor, so I'm going to leave my slope as 9 over 2. But just so we know what 9 over 2 sounds like, that's 4.5. That's between 8 over 2 and 10 over 2, so this is about 4.5. But we're going to leave it as the fraction, 9 over 2. Not too bad, right? It's just a matter of knowing how to use negative signs, and we've mastered that already. So there are questions 2 and 3. Your turn. Go ahead and use the slope formula to find the slope of these two lines that are given. And then we're going on to number 3. We're going to now use slope to figure out how to answer some questions. Okay? So we are given a table, and it is told that it shows the total cost of fruit per pound purchased at the grocery store. We're going to use the data to make a graph, and then find the slope of the line and explain what the slope of the line means. Well, first things first, let's graph this data. Okay? So I have not x and y, I have pounds and cost. So I'm just going to do P and C. And the one that I get to pick, apparently, is how many pounds. And then the dependent variable, the one that is told to me, is the cost of it. So I'm going to label my axes right now, P and C. And I'm also going to label my graph. I'm going to bring this down. I'm going to label my graph the same thing that my table is labeled. And this is the cost of fruit. Now, there's one other thing I have to do. I need to actually put in some numbers. It looks like the cost of fruit, the pounds, goes from 0 to 15. So I need to start here at 0, and I need to get this to 15. So how about every 2, I will do 5. So 5, 10, 15. Let's do it every 3. I do have enough room to do that. So I'll do it every 3 instead. 0, 5, 10, and 15. And then for cost is going to go between 0 and 45. So I need to make sure I can fit 45 on here. And let's see, I guess I will go every line is 5, so every 2 lines is going to be 10. So 10, 20, 30, 40, 50. And notice all of my numbers are positive because it doesn't make sense to have negative pounds or negative cost of something you're buying. So I am not going to need any of this stuff, just the first quadrant. Now what I'm going to do is plot my points. I have 0, 0 as 1 point, so I'm going to plot in blue. There's 0, 0. I have 5, 15. So I go over 3, up 3 to get to 5, 15. There's another point. I have 10, 30. I go over to 10, up to 30. That's right here. And then finally 15 and 45. Go over 15, up 45. And there I have it. And I'm going to connect this with a line. Okay. Let's see what I've got. I need to make sure I have arrows on both ends. Okay. And now I'm going to make my line. Okay. So that didn't work so well. I'm going to adjust this arrow a little bit. It's got to end there. Okay, and I guess the only place I need an arrow is on the right side. So just like that. And let's see, did it work? No, it didn't, so I'm just going to draw it. Okay, so this is my graph, cost of fruit, and let's see, and I have pounds of fruit and cost of fruit. Okay? So I'm just going to then find my slope and figure out what the slope means. I'm sorry, the video did not pause. I just had to step away for a second. Okay, so last thing to do is find the slope and what it means. Slope here is the change in y divided by the change in x. Okay, so when I go, I'm going to pick 2 points. Let's say this one here, 5, 15, and this one here, 10, 30, and I'm going to find my slope. First I do my rise, which goes from 15 to 30, so my rise is 15. And then my run, the amount over, goes from 5 to 10, so that's just 5. So my slope is 15 over 5, which is equal to 3. Now if my slope is 3, think about what I actually did. I went up 15, which means I'm going up in cost, dollars. And when I went over for my run, I'm going over in pounds. So really, this was $3 per pound. And that's what my slope means. It means that for every pound of fruit, I am going to pay $3. Okay? So that is what the slope meant in this case. You have to think about what you're actually going up, what you're actually going over. Here, the slope 3 represents how many dollars I am going to pay for each pound of fruit. Okay? Now I am going to go on to my, there's going to be a your turn question, and then I'm going to go on to my final slide. We're going to summarize slope. Slope can be one of four things. It can be positive. That means we're going up and over, so it looks kind of like this. Slope can be negative. That would mean our rise is actually negative, so we'd be going down and over. Slope can also be zero. That means we're not going up at all, even though we're going over. And then slope can be undefined. That means we're going up and down, but not actually going over any. And the reason this is undefined is because we do rise over run. And our run is actually 0, so we're going to have a number that's dividing by 0. Let's say it was 2 divided by 0. We cannot divide by 0, so we have something that's undefined. Remember, dividing by 0 is one of those no-nos that you can't do. Okay, so these are the four possibilities we can have for slope, and that is it for this lesson. We are done.